Section 3.5, just like Section 1.5 and Section 2.5 is our word problem section for the chapter. It's going to come up in Chapter 4 that the last section of the chapter is word problems as well. I don't know why I do that, I just do. I cut and pasted some stuff from Section 2.5. We're doing more businessy kind of word problems. And so just a few concepts that we have to remember. The price demand function that we talked about in Section 2.5 comes back again in here. Basically that, demand and the price are related. Usually as price goes up, demand goes down. As price goes down, demand goes up. And the price demand function that we use in Section 2.5 describe the relationship between the amount of units demanded for a product and the price of the product. And very specifically, if you gave me a number of units, I could figure out the corresponding price to sell that many units. So real quickly, here's a simple price demand function that gives us the demand. If you tell me how many units of a product want to be demanded, I can tell you the price. If we plug 20 in for X, X stands for the number of units, so it says the price to sell 20 units. Plug the number in, do the algebra on your calculator, and you get 25. And again, the number in the parentheses 20 represents the number of units. The number I get out is the price needed to sell that many units. So a price of $25 will sell 20 units. And again, this is just all cut and pasted from the section. I don't know how much you remember or not, but just to make sure that's fresh in your memory. I'm not going to go through the detail. We already went through the detail. And then, how do I find the revenue when we sell 20 units at $25? Well, revenue is just price times quantity. Price is $25. Quantity is $20. The amount of revenue that would be generated from selling 25 units of this product at $20 each is $500. And remember, we used the price demand function to create a revenue function. We just use the formula revenue as price times quantity. And if we have a price demand function, we can call the price demand function the price part of the revenue formula, and the quantity is just X. If you multiply a price demand function by X, you get a revenue function. And then we use the revenue function to compute the same thing. So this is complete review, just cut and pasted. The important thing is this price demand function, we're going to see again in this section. The X in the price demand function is the number of units that you want to sell of a single product. What you get out is the price. And if you multiply a price demand function by X, you create a revenue function. And that's just formalized here. Revenue is X times the price demand function, where X is the number of units and P of X is the price. I wrote this formula down in Section 2.5 and didn't wind up using it, that profit is revenue minus cost. So for P of X, which is profit, capital P is profit, small p is price demand. Profit is revenue minus cost. Big P is profit, big R is revenue, big C is cost. And that's all the profit of selling X units equals the revenue from selling X units minus the cost from selling X units. So when I do a couple problems from the section, I thought I'd start with the ugliest one. It's not particularly ugly, but I want to do Section 3.5, problem 6. I think there's only 6 problems in this section. And problem 6 in this section talks about the Double B Corporation. And they analyze production costs for one of its products. And they determine the daily cost function for this product is this, where X is the number of units produced in the day. And the price demand function for this product is P of X equals negative 1/2 X plus 150. And then the questions that I'm supposed to do for this, and I've already done them, is first create a revenue function, then create a profit function. And these are easy to do. Let me get some paper. I don't seem to have any around. So if I'm asked to create a revenue function and I have a price demand function, a revenue function for a single product is just price times quantity. So for part A, to create a revenue function, it's just the quantity times the price, or the price times the quantity. X is the number of units of this particular product, and P of X is the price. So my revenue function is going to be found by taking X and multiplying it by negative 1/2 X plus 50, plus 150. And I just clear the parentheses, and I get my revenue function to be negative 1/2, and then I multiply the X times the X and get an X squared, and then multiply the 150 by the X and get 150X. So this is just my revenue function that part A of question 6 asks me to create. Part B wants me to find a profit function. Well, I'm going to use the formula that profit equals revenue minus cost. So I can create a profit function, P of X, capital P of X, as opposed to lowercase p of X, equals revenue. Revenue is negative 1/2 X squared plus 150X minus cost, which is this, and because that's a trinomial, I need to put it in a parentheses. So revenue minus cost. Cost is 1/2 X squared plus 20X plus 500. Now I'm just going to clean out get rid of the parentheses, combine like terms to create my profit function. So my profit function is negative 1/2 X squared plus 150X. And now I'm going to start clearing the parentheses and stacking. So when I clear the parentheses here, I'm going to get a negative 1/2 X squared. Instead of writing it horizontally, I'm going to write it vertically. When I clear the parentheses, the 20X becomes a negative 20X. And when I clear the parentheses, the positive 500 turns to negative 500. Now I'm going to combine these. In the coefficients of the X squareds are both negative, so I'm going to add them and keep them negative. I'm going to do negative 1/2, I think minus 1/2. Minus 1/2 would be fine, or plus negative 1/2, but you get negative 1 when you do that. Negative 1/2 minus 1/2, or negative 1/2 plus negative 1/2 is going to give me negative 1 X squared. And then these X terms have opposite signs, so I'm just going to subtract and get 130X. And I'm going to bring down the minus 500. This is going to be the profit function that I'm asked to find in problem 6 in the section. And that's not particularly hard for the worst problem in the section. That's not ridiculous algebra. So done with part A and B already. Let's move on and answer the calculus. So the calculus for this problem wants me to figure out how many units do we need to sell to maximize profit. Well, this is just a maximization problem, and we know how to find maximums and minimums using the first derivative. So that's what I'm going to do now. I'm going to do all the first derivative tests to find the maximum point. So we have this profit function that I'm trying to maximize that we figured out in part B. The profit function is negative 1 X squared plus 130X minus 500. This is the function that I want to maximize. Let me find its derivative. So the derivative of the profit function is 2 times negative 1, which is negative 2, and then x to the first power. Lower the exponent by 1. The derivative of 130x is just 130. The derivative of minus 500 is 0. Doing all the first derivative tests, so now that I have the first derivative, I'm going to set it equal to 0 to get a critical number. When I do that, I get negative 2x equals negative 130. Divide by negative 2, divide by negative 2. This gives me x equals to, I believe, 65. Let me create a number line with, instead of negative infinity on the left edge, 0 on the left edge, because the number line represents the number of units of product that the company needs to produce, and it can't do less than 0. It probably can't even do infinitely many. There's probably some realistic right end here that's not infinity. And if I created the problem with the little domain, like 0 is less than or equal to x less than or equal to 500, I'd put 500 or some other number here, some production max. So I've got my critical number on a number line. Instead of having negative infinity, I have 0. Shut my light off because I get a ridiculous shadow when I put that light on. Sorry, I forgot about the shadow until I looked over what's happening on the video. So those are my intervals. In the first interval, I'm going to pick, let me just pick 64. I'm just so used to picking numbers right up against the edges to figure out if I'm increasing or decreasing. In the second interval, I'm going to pick 66, plug them into the derivative. I'm going to do p prime evaluated at 64, which is going to be negative 2 times 64 plus 130. I'm going to do the same. I'm going to evaluate the derivative at 66 and get negative 2 times 66 plus 130. And first one, negative 2 times 64 plus 130 gives me 2. So the graph is increasing. And in the second one, negative 2 times 66 plus 130, I get negative 2, so the graph is decreasing. This is good because now I know that I have a maximum point because the graph goes from increasing to decreasing, so that x equal to 65 is a maximum point. It's the number of units that are going to give the maximum profit. So doing the derivative test that I just did, it's going to clue me into that this critical number is in fact the x-coordinate of a maximum point. Now, for this particular function right here, $65 is going to be the 65 units is going to be the number of units that maximizes profits. Now let me figure out what the maximum profit is. How do I figure out what the maximum profit is? Well, I use my profit function and plug 65 in for x, because this is just the x-coordinate of the maximum point. To get the y-coordinate of the maximum point, I plug the number into my profit function. My profit function works like the x, so my profit function, the points on it, the x's are the number of units, and that's what I've just found right now. I found the x-coordinate of a maximum point, and that's going to be the number of units. In this case, it's 65 units. And the y's are going to be the profits that are earned by selling that many units. And so if I just take 65 and plug it into the profit function, apparently I get $3,725 as a profit. So the maximum point for this particular function is 65 units, $3,725 for the profit. So when I went to answer what is the maximum profit, I just plugged the 65 units, which is the number of units to maximize profits, put the 65 in and got $3,725 for the profit. Now here's a new question. And what price per unit must be charged to maximize profit? Well, I know the price demand function works just like this. I have this price demand function. If you tell me the demand, I can tell you the corresponding price. So that's how I'm going to do this. I'm going to use the price demand function, the lowercase p, price demand function is negative 1/2 x plus 150. If I put a number in for x, that number is the number of units that we're going to sell. The value that I'll get out will be the corresponding price. So to figure out the number of units, the price to sell 65 units, I just plug 65 into the price demand function. And I do the algebra, and what comes out is the price. So negative 1 divided by 2 times 65 plus 150. I'm getting close to the edge of my paper here. I can't really tell where it's at. I don't want to write off the edge. So this tells me that P of 65 that says the price to sell 65 units of whatever this product is $117.50. So the price per unit to make the maximum profit, that's the price per unit to sell 65 units, is $117.50. And, did I not type up an answer to that? Doesn't that surprise me? Oh, there it is. There's my $117.50. And let me just show you a graph of the profit function. Here's how the profit function looks. Each point on the graph has the number of units and the corresponding profit. And visually now, hopefully you can tell that the point 65.3725 is a maximum point, and you can maybe see visually that if I sell less than 65 units, I'm going to be down here on the graph of the profit function of a lower profit. If I sell something over here more than 65 units, my profit is going to be the y-coordinate of a point down here, which is also less than 37.25. You don't need to sketch a graph, but this is just to help you visualize if you're a visual learner. That's kind of everything for our section. That's problem 6. I'll do one more problem. I'll flash one of your problems up on the screen. They're all just repetitions of this. So if you wanted to, you might be able to pause the video right now and do exactly what I did on the example for number 6. It's the same questions. Use the price demand function to create a revenue function. Use profit equals revenue minus cost to make a profit function. Really, if I want it to be lazy, just find the first derivative, set it equal to 0, bank and hope that it's a maximum point, and think that's the x coordinate of the number of units to make my profit. Plug that answer to part C into the profit function to figure out what the maximum profit is. And for part E, to figure out the price, take your number of units, plug it into the price demand function. So I'll just do one more problem of a nice pleasant section, and let's see how much I can just squeeze onto here. So a company makes a single product. The cost function is given by cost equals 0.5x squared plus 20x plus 200, where C of x is the total cost to produce x units. The price demand function, it should probably say here, the price demand function is given by P of x equals negative 2x per 100 plus 100, where P of x is the price to sell x units of the product. How do I create a revenue function in part A? Super easy. Revenue is price times quantity. So the revenue function is quantity times price, or price times quantity. Those are that multiplication is commutative. So my revenue function I just get by clearing that parentheses, and I get revenue is negative 2x squared plus 100x. Part B wants me to create a profit function. Well, I know that profit is revenue minus cost. I just figured out the revenue function is negative 2x squared plus 100x. Now I need to subtract the cost function in a parentheses of 0.5x squared plus 20x plus 200. Clear the parentheses and I'll get my profit function quickly here. So my profit function is going to be the revenue function minus the cost function, and let me clear the parentheses and line things up. Here I'm going to get negative 0.5x squared and then minus 20x and then minus 200. I get the profit function is minus 2.5x squared plus 80x minus 200. That's my answer to part B. So my profit function is minus 2.5x squared plus 80x minus 200. Now I'm going to get lazy on part C and confirm that my critical number is a maximum point by lazily graphing. So how many units must the company produced to maximize profit. Let me find the derivative of my profit function. I'm going to go negative 2.5 times 2 and get negative 5. I'm going to lower the exponent and get an x to the first, negative 5, and then plus 80. I'm going to set this equal to 0. So negative 5x plus 80 equals to 0. Minus 80 gives me negative 5x equals negative 80. Divide by negative 5, divide by negative 5, and I think that comes out to 16. I think the number of units to maximize profit is going to be 16. And instead of doing the formal calculus to show that this is a maximum point, I'm just going to visually verify it by graphing this parabola and making sure the point that has x equal to 16 is the maximum point. And so let me take this profit function. I'm going to just confirm that x equals 16 is the x-coordinate of a maximum point by taking the function, shoving it in y1, going negative 2.5x squared plus 80x minus 200. I know my window, my x-min and my x-max have to at least accommodate 16. So my x-max needs to be bigger than 16. Let me just make it 30. And then for my y-mins and y-maxes, I'm going to peek at a table real quickly and look at the y-coordinate next to 16 to give an idea what my table needs to be. So I'm going to go second in table, and I'm going to scroll down till I find 16, because that's what I think the maximum profit is. That's 440. I don't care what my y-min is, but my y-max better be bigger than 440. I'm going to set my y-max at 500 just to get a picture that encompasses the entire parabola. So I have my function in, hit my window button, 0 units for the minimum number of units, anything bigger than 16 for the maximum, and then the y's are the profit. Negative 10 would be a loss. I'm not worried about losing. I'm trying to maximize profit here. I'm going to probably have positive, and then 500. And now let me just graph this. And make sure that that vertex is at 16. Let me just go second, calc, hit enter on value, type 16, and that's beautiful. That point right there, the point where x equals 16, that is a maximum point. So without doing calculus, I can kind of press buttons just to save time in the word problem section. That is a maximum point. So the answer to problem C is the 16 units. To get D, the maximum profit, it is $440. If I want to do D straight out, I'm going to use the profit function and plug 16 in. I'm going to do the profit function evaluated at 16 is negative 2.5 times 16 squared plus 80 times 16 minus 200. Let me just do this from the main screen to show you that it comes out to that number. Negative 2.5 times 16 squared plus 80 times 16 minus 200, which was just plugging in 16 into the profit function, and that's what my calculator did when I did the second calc value. That gives me the profit. What is the maximum profit? The answer to part D is $440. Now I want to know the price to get that particular profit. I'm going to use the price demand function, and I'm going to plug 16 in for X. So the price to sell 16 units is negative 2 times 16 plus 100. I think that comes out to 68. Just negative 2 times 16 plus 100. It is 68 bucks. So the answer to part E, the price to maximize the profit, the price to sell 16 units is $68. And that's kind of all I really want to do. There's another problem, but it's no different. Let me flash your problem 3 up. Exactly the same questions, exactly the same situation. And my problem 4 would be nothing new. It's exactly the same. It gives me a price demand function to make X units of a product, gives me a cost function, asks me to create the revenue function by doing X times the price demand function, create a profit function by subtracting revenue minus cost, take the derivative of the profit function, set it equal to 0. That should give you the number of units to maximize profits. Sketch a graph just to make sure that it really is a maximum point that at that value of X. Plug the value for C into the profit function to get the maximum profit. Plug the answer for C into the price demand function to get the corresponding price. And that's the entire section. So it's a friendly section. It's just 6 problems in the section. They're all essentially the same problem. I just did 2 of my even ones. There are 3 even ones, but I skipped 1. But it wouldn't be anything new. So hopefully this feels good. And now we can just prep out for the test, doing the practice test. And then I'll be done with chapter 3 and just have 2 chapters left.